Today I'll talk a little bit about, I know we're at the AI conference, but how not every problem needs a generative AI solution. I also want to cover a few jargon-free ways of building AI applications. I want to cover one of the critical problems that we see at LastMile, which is the problem of evaluating AI applications, and what we see as the current state of the art for that. And then obviously I want to talk about what we're building to solve some of that at LastMile AI. I'll try to end a little bit early just so we have a room for some Q&A as well. So a little bit about me and the company. I'm the CEO of a company called LastMile AI, and our mission is to enable software developers who may not be ML experts to be able to build production-grade generative AI applications. And we think that the future of AI application development is going to be driven by developers, and we cannot expect every developer to become a data scientist. So a little bit about me. I've been building developer tools my entire career. Before LastMile, was working at Facebook on some of the ML developer tools there, like Jupyter Notebooks, model management and experimentation platforms. I also worked for a bit on VS Code at Microsoft and compilers and build systems and things like that. So I'm very passionate about developer productivity in general. So there's a lot of hype around generative AI. Nobody needs to be told that. But I think it's important to see what problems actually need a generative AI solution. Because AI innovation is accelerating. Models are improving. We're having a lot of cost reductions as well. But we're also at the risk of trying to see every problem as an AI problem. And it isn't. First of all, just a small example is chat interfaces are being added everywhere, even though there are visual elements like buttons and UX design that has existed for a long time that is sometimes even more efficient than talking to a computer. And the second thing is not every AI problem is a Gen AI problem. And by that I mean there's a long history of research on things like information retrieval, IR and recommender systems. And sometimes when we talk about the shiny new thing, we forget about the predictive ML and well-defined techniques of doing the same thing. And so I'd caution against, trying to think of everything as a Gen AI problem. So what I want to cover is basically a step-by-step guide. I'm not going to be able to go into detail in everything, but what we see as the principles of building AI applications that work in production. And a lot of this talk is driven by some of the learnings we've had from working with enterprise customers who have a much higher bar for what production grade means for AI applications. And so at a very high level, what we see is it takes days to build a prototype. We have lots of great tools out there. You can even invoke APIs like the OpenAI SDK to get pretty far and build something reasonably useful in a matter of days, if not hours. But then to actually take that into a production-ready application that works reliably, covers all the edge cases, that is a months-long endeavor. And a lot of engineers are currently not equipped with the tools they need or the skills they need to be able to bridge that divide. And so I want to cover some principles today on what that looks like. So first of all, again, is this a hammer looking for a nail? First, really, it's important to define whether you're just trying to add an AI feature for the sake of it, or if there is an actual business problem that can uniquely be solved with the introduction of generative AI. And so some examples we see is someone came to us and said, we really want to make sure phone numbers are of a specific format. And that is a regular expression problem, not an AI problem. Similarly, if you're trying to do mathematical calculations, use a calculator. And you can still have an information generation phase that combines the different sources of information that uses an LLM at the end, perhaps, as a synthesizer. But you don't need to solve everything with Gen AI. And so the second thing is, if the solution still requires some kind of application of generative AI, and examples of that are classification problems, intent recognition, natural language processing, some of these things that LLMs are really good at, then we can go to the next step, which is let's cut through some of the hype and jargon. There are a lot of distractions out there today because everybody's trying to talk about the shiny new thing. I remember last year when we were fundraising, a whole bunch of investors asked us about what our opinions are on vector databases. And then everybody started talking about RAG. And I think now we're all talking about agents as a collective AI community. And tomorrow, I'm sure there'll be another thing, right? And so it's really important to figure out what are the fundamentally new innovations happening and where are we, kind of falling for some of the marketing hype as well. And so the thing that I always tell our customers is we don't need to reinvent everything. So for example, LLM observability is just distributed systems observability in a nutshell. You can add LLM-specific capabilities on top of that, but let's be real, it is observability for distributed systems at the end of the day. Similarly, multi-agent workflows with memory sounds really fancy. Usually it means workflow orchestration with some persistent state. And agents in general, at least for the enterprise customers we work with, oftentimes are tool use and sometimes multi-step tool use. And we'll talk about agents in a bit. And similarly, prompt management, we hear a lot. One of the things we recommend customers is just use source control. It's important not to store prompts as strings, but you can also store and manage and version prompts just fine with source control and GitHub, just like you version control your source code. That's actually one thing that is important, like version controlling your prompts. But I think it doesn't need a whole new product line just to be able to do this. The third thing is understanding the current limits of the state of the art. And it's in order to build a robust application experience, you first have to figure out where are we at the very cutting edge and just pull back from that a little bit. And so at a very high level, it's really good for enhancing retrieval applications today. You can use LLMs in all sorts of interesting ways for information synthesis, for classification problems, intent recognition, for data augmentation. And it's some of those, in fact, like back office workflows that we're seeing enterprises really excel at using AI models for. The thing it's not yet great for is unconstrained agentic workflows. And by unconstrained, I mean you give a very abstract task to an LLM, you ask it to figure out what the plan should be completely autonomously, and then you ask it to execute on that plan. But you can get a lot of the way by constraining the problem, by making it more deterministic. And so, for example, you can define a state machine of interactions that are possible for your application and use that to constrain how agents interact with each other. So an example of that is we worked with a customer that's building a code management tool, and they're using multiple agents for that. And so for that, you know that there's a build refactoring agent, a package manager, a class refactoring tool, etc. And because that's a very constrained domain, you can actually define a state machine of interactions that are possible between these different agents. So you don't have to have the LLM figure out a plan every single time. Also, what we've seen is almost every practical use case in enterprises currently boils down to information retrieval of some kind or another. Companies have tons of data, and they're trying to build reasoning and synthesis pipelines over that. And they find RAG or other kinds of techniques as the first entry they have into building information retrieval systems. But I want to clarify that that's not the only way you build information retrieval systems. And so a lot of customers are not familiar with recommender systems from the past, or it's almost like trying to build a Google search engine internally from scratch. And so it's important to figure out what the limits are of the current state of the art and apply what has existed for a while to the problem we're dealing with. So now it's time to build a system. And so one of the things we recommend is avoiding unnecessary frameworks, except to prototype very quickly, because those frameworks do help you get started very, very rapidly. You can get something useful in 100 lines of code, but oftentimes they slow you down when you're actually trying to iterate and perfect your own application. like I mentioned earlier, for retrieval systems, there's tons of research in the past from predictive ML days of how to build a retrieval system. And so some examples of that are for topic extraction. You can check out an open source repo called BERT Topic. And it even uses LLMs now, like a llama model for topic extraction, but it's built on more deterministic and interpretable ways of doing topic extraction that have existed for several years. The other thing is it's still a data pipelining problem where you still need a roles-based access control and data refresh and re-indexing policies set up in order to build a proper retrieval system. And so, for example, you can chunk data and you can put it in a vector DB, but if the original data had boundaries on data access, then those permissions need to be propagated all the way through. And a lot of the time when we've seen initial versions of retrieval systems built, we see all of that important metadata lost along the way. And so just building those controls that a proper rules-based access control system needs is pretty critical. And finally, I want to flag this one example we saw from Meta recently, where they built a system for root cause analysis of incident responses, so SEVs that happen at Meta. And they were able to get a 42% accuracy rate on root cause analysis through the system. And what it involved was a fine-tuned llama model that was trained on historical data from SEVs that had happened in the past. And they were able to get that using an LLM as a ranker and recommender to 42% accuracy, which is really incredible because that means that for 42% of the issues, it was able to identify the commit that caused the failure. The fifth step in all this is setting up, if you have the application, you want to set up the harness around your application. And this involves guardrails, this involves monitoring, observability. There's a really great post by Chip on how to build a generative AI platform. I'd recommend folks take a look, Google that. It's gotten pretty popular. But it just shows and highlights all the things that are the harness around your application that are still necessary to launching into production. Getting the application to work well is not enough. There's steps after that that you need to take in order to build a proper application. And so in this case, some examples are you want guardrails for inputs and outputs. And sometimes these are just rules-based things that you constrain behavior based on the subject of your application. In other cases, it might be an AI model that's acting as a guardrail. Then there's observability and monitoring. And again, this is standard distributed system stuff. This is something you would set up when you launch a service anyway. And finally, you do want a feedback loop of data coming back to the developer. And this isn't just for fine-tuning. It's also for just seeing how the application is performing in the wild and having basically a performance benchmark of how the application is doing overall and how to improve it. And that brings us to not step 6, but actually step 0, which is the last mile problem of evaluation. So it's a very simple proposition. Like, how do I measure the performance of my application? That's effectively what we mean when we talk about AI evaluation. But it fundamentally breaks down the software development lifecycle because AI applications are non-deterministic. And so it's something that we as software developers have not really encountered. You think of like writing unit tests and integration tests and having test suites that are run, and you actually disable tests that are non-deterministic, and in AI applications, you're fundamentally introducing non-determinism as a feature. And so how do you evaluate an application like that requires a fundamentally new way of thinking about testing and performance benchmarking. So the current state of the art for that is using an LLM as a judge. And so we're basically back to giving the question back to GPT-4 and saying, hey, score this response 1 through 5 given this criteria. And that works well as kind of like a rubric, but what it breaks down at is it's first of all expensive, so you can't run this every single time. It takes time to run, so there's latency constraints. But more importantly, it's unreliable because LLMs were fundamentally not designed to be evaluators. And it's almost like a tautological statement, where you're asking an LLM to evaluate an LLM. And people go around like all sorts of hoops to justify that by like having a consensus model of asking multiple LLMs to judge these. But ultimately, we're like not addressing the root of the problem, which is this is not the right way to evaluate things. And so what we've been building at LastMile is a set of capabilities to build custom evaluator models that allow you to evaluate your AI application and get a numerics metric and score out of it. And so what this means concretely is, let's take retrieval applications like RAG applications. We have a bunch of evaluator models that are extremely small. They're 400 million parameter models. They're based on BERT-based architecture, so they're still transformer-based models, but they're not LLMs. And the final response they generate is a numeric score between 0 and 1, giving you a quantitative metric for what you're measuring. And so for a retrieval application, one example is faithfulness, which is how faithful is, for example, the response that the LLM produced to the data or the context that I fed it. And that can be a proxy for measuring hallucinations. Similarly, answer relevance could be another metric that you want, where you want to see, did the LLM or my application answer the question that the user asked? And you can have a suite of these metrics that we enable by default. But the really important part about this is we enable you to fine-tune a custom metric for the context of your application. And so every application we've found has some different business metric criteria for what quality looks like. In some cases, enterprises want to measure brand tone. And so how do you quantify brand tone? And so what we enable them to do is actually provide a set of a rubric of how they want to quantify their metric. And this could be like a document on brand tone, for example. We use that to synthetically generate a data set that labels examples as good or bad. And then we use that data set to fine-tune a model that gives you a numeric metric at the end. And the nice thing about this is you don't need ground truth data sets to get started, but you could use human in the loop as a labeler to say these examples for brand tone, for example, are good, these examples are bad, and then at the end of that process get a fine-tuned model that can basically replicate that human judgment extremely accurately. And so we believe that this set of customized metrics can get you a suite and a dashboard of application performance metrics that break the dependency on LLM as a judge and can go back to a more scientific way of measuring application performance. The other thing I want to cover a little bit is guardrails. So guardrails, what I like to say is guardrails are just evaluators that are run online, because if your evaluation metrics were able to be run fast enough, why wouldn't you just run them in real time in the application flow to prevent the issue from happening in the first place? And so, for example, if you detect a hallucination, if the faithfulness score is low, then you should be able to just block that request or retry that request before it even reaches the user. And so what we've committed to is setting up a baseline performance criteria for these auto eval models where it's extremely fast to run so that it can be run online as well as offline. And so some metrics for us are currently they're able to be run in under 300 milliseconds on a CPU, which matters because a lot of enterprises don't want to set up a GPU cluster just for eval purposes. And also they're very cheap to operate because they're 400 million parameter models. They don't break the bank if you ran them on every single trace that came your way or every single request that the application was serving. And an important thing is you can also train custom guardrail models. What we've seen from some customers is they want to constrain the input to an application. Or let's say you're an energy company and you have a nuclear division and you really don't want your AI application to talk about your nuclear division, which is essentially a custom guardrail. The way you would do that today is by adding a system prompt like, please don't answer questions about XYZ, which is very unreliable, and there are all sorts of techniques of circumventing that. But you could train a custom evaluator model that basically gives you a numeric score of between 0 and 1 of how likely you're basically someone is breaking that guardrail that you've set up. And that way you can guarantee that those responses or those inputs will be rejected. So this is what we see as an application dashboard. It should look very familiar to people who've built applications and services before. Our goal is essentially to be able to build back the kind of things that software developers are used to when they've been doing application development for so long, and for them to just have AI applications as yet another part of their SDK. You know, it shouldn't be something fundamentally new. It should just be an add-on to a toolkit that you already possess. And so I'll be here afterwards. I think we have a few minutes left for questions as well. We're going to be launching the auto eval product that I mentioned as a service next month. So if you want to sign up, here's a QR code. And also happy to get in touch with anybody afterwards as well. Thank you.
So we do have time for a couple questions. We have a couple of folks in the back, and they have microphones in their hands. Make eye contact and get your question asked.
Hi, I appreciate you going over the concept of guardrails, and are you able to speak on it about how it can relate with fuzzing?
Sorry, can you repeat that?
Can you provide any sort of insight on how it could relate with fuzzing? So the traditional security mechanism would be to like run a fuzzer over. How does guardrails apply in this way?
That's a great question. So there are many different kinds of guardrails. There are also rules-based guardrails, like regular expression-based things or other kinds of applications. This is a specific capability that you enable as part of a guardrail suite. It's not the only thing, but what we call this is model-based guardrails. And so, for example, if you want to set up a rule where you want to disallow any questions that are irrelevant to the purpose of your application, you should be able to train a model, an evaluator or a guardrail model that understands what the purpose of your application is and can evaluate any input and give you a score of whether that's relevant or irrelevant. And so this is just one part of what a wider guardrail suite would look like. We think this is an important piece, and so that's why we're focusing on this. But to your point, there are other pieces to properly securing an application that shouldn't be ignored.
Yes, I can't see you, but can you speak a little more about the role or make a prediction about human in the loop as far as data response evaluation, where you think that's going?
Yeah, that's another good question. I think it can't be a prerequisite to getting started, but I think it's irreplaceable in many ways. And human in the loop, I think people often think of it as like large-scale labeling tasks because it's usually like data intensive, and we've gotten used to like LLM training. And so in many cases, people get scared by the mention of human in the loop. But what we see is you can actually have human in the loop for, let's say, a few hundred examples, right? Which means if you're a developer team of 5 people, that's like every developer labeling 40 examples. That's very doable even within the context of a day to create a good set of data. But I do think there is a room for basically having both human in the loop as well as synthetic data augmentation with LLMs, and they can actually interoperate very well. So let's say you have 200 high-quality labeled examples by a human being. You can then generate 2,000 examples with an LLM using that initial set as the baseline. And so I see that as basically essential to getting good quality evaluators in the end. But I think that needs to be more methodical because today it's just a scary thing to get started with. I think because there is no workflow in place for how you even start with like labeling, go from human in a loop to fine-tuning, to getting a model, to hooking that up into production. So I think that workflow needs to be well-defined in order for it to be a little bit demystified. But I think it's here to stay, and it's going to get more important.
Last question?
Yeah. Thanks for the talk. I'm from here. I'm here. Oh, sorry.
Oh, sorry. Yeah.
I'm from Intuit, and we are rolling out a custom coding assistant for our developers. So you talked about the synthetic data creation in your auto eval product.
Yeah.
Does it work for coding tasks?
It does. We're working with a couple companies actually that have coding assistants. Happy to chat afterwards as well.
Yes.
And it depends on how you want to generate synthetic data.
Yeah.
It can either be synthetic data sets and entirely, or it can be labels for evaluating quality of
Yeah, exactly.
responses.
Okay.
And it does work. And you can we have a couple of techniques for generating that data synthetically.
So one more question. So we recently rolled out multi-tone conversations.
Yep.
So does auto eval work for that? Because it has to take like all the questions to come up with those codes, the correctness, faithfulness.
It does. That's another good question. So one thing I forgot to mention is we've done a lot of work on effectively infinite, but like up to 128K context window length for these evaluator models. And I'm happy to go into more detail afterwards on how that works, but there's a windowing technique that works pretty well. So you can even use a 400 million parameter model, but have effectively 128K context window for this.
I see. Okay, all right.